Right, grade 9s. What we're going to introduce now is, like I mentioned, a little bit of the physics side of life when it comes to natural science. Okay, that's what we're going to do. Okay, to begin introducing the physical sciences part of natural science. Okay, we're going to start by having a look at some of the elements, compounds, etc. of the periodic table. Okay, so lots of chemistry. Okay, so we're going to just start introducing this, and the first topic, rather, of the introductions. Let me just start all the way from the top here. Okay, there we go. Is that of compounds. Okay, may or may not be a new word for some of you. Okay, so we're going to start by just having a look here. So if we have a little mind maps are life. They are, of course, I would say not standard, or I would say standard, but I mean they are great help. Okay, so what we're going to start off with is reviewing. Okay, so when we review some elements as well, we are going to revise. All right, so we're going to review and we're going to revise. Okay, now what are we going to review? Well, we're going to review some elements, and we're also going to review some compounds. Okay, then a little later on, we are of course going to have a look at the periodic table. All right, or its full name, the periodic table of elements. Okay, which we obviously, if you decide to choose physical sciences as your subject in grade 10, would obviously make extensive use of. And then we're also going to revise, of course, the names, right, and introduce names of compounds. Okay, so that's our little map. Okay, we know where we're going, we know where we're headed, we know what we're gonna do. Okay, so just to remind you on the reviewing and revise little bubble there, that in grade 8, what have we learned? We learned about elements. All right. More specifically, an element is a pure substance. Okay, that's how we know an element as. Okay, it's a pure substance that has only one kind of atom. Okay, maybe we can take that down for a bit of revision. Okay, element. Okay, shorthand note. This one, it's a pure substance. Right? One kind of element, or one kind of atom, so just one atom rather. That's what an element is. Cool. We know that element also cannot be broken down into simpler substances, right? So an element is, in fact, its simplest form. Okay? Cannot be broken down into simpler substances. We use 1 or 2 letter symbols for an element's name. Okay, so let's take an example here. H, we would use that for hydrogen. Okay, so this is not hydrogen gas necessarily, but on the periodic table, hydrogen is labeled as H. Okay, as per periodic table. Alright, cool. And there's other examples such as C for carbon, Ca for calcium, Cl for chlorine. Now a new one, well, may or may not be new, but a compound, okay, is also a pure substance, okay, so we also denote that. It is in fact a pure substance, okay, nothing impure right here. It's a pure substance, okay. The only difference is element has one kind of atom, compound has 2 or more kinds of atoms. All right, cool. So a compound, for example, would be Water. All right, what is it good for? Absolutely loads of stuff. Water. Okay, and we know its chemical formula is H2O. All right, lovely. Okay, now I mentioned something as well, which was, of course, a chemical formula. So I'll change that into a different color. There's an example of chemical formula right here. But we need to define it, remind ourselves what it is. Okay, chemical formula. So what does it show? Okay, it shows the elements. Right, it shows the elements present in the compound to be, or to summarize. Okay, it shows the elements that are present within the compound. Right, it also shows how many of, or how many atoms of each element. So example, we have here H2O. We can see we have 2 hydrogen atoms and 1 oxygen atom. Right, for example. All right. So that's some of the key words that we learned in grade 8, or last year, I do believe. All right, if my memory serves me correct. Okay, that's about just the review and revising when it comes to elements and compounds. All right, so just put that in play. We've had a look there. All right, here we are. Now, also in grade 8, we obviously learned about the periodic table of elements. We learned about it, and we possibly have encountered, all right, a little bit of it, of course. Okay, so what I have here is a graphical representation of a periodic table of elements. Now, when we are learning the periodic table of elements in the current grade that we are currently in, it is always good to find a periodic table that's well colored. All right, it's colored up. All right, and obviously different colors mean different things. Right, our brain thinks in pictures, in pictures of color. So it is fantastic to be able to see a periodic table that has lots and lots of color in it, so we can remember it. Because when we get to grade 10, 11, and 12, we won't see color anymore, but we will, or we won't see it on the pages. We won't see it in the exam. In fact, even now, you won't see it in the exam either. But when you're learning it, it's a good technique to have a periodic table that is well colored. And this one also has a key. All right? It also has a key for us to be able to see which colors represent which group. Okay. But if we go back ahead just before grade 8, okay, we will notice that in grades 5, 6, and 7, we learnt that elements can be classified into metals, non-metals, as well as semi-metals. Okay, which we see here. We have the different metal groups. All right, so we have metals, right? We have non-metals, and then we also have semi-metals. All right, metals that are not entirely metal. Okay, we're going to go through a few of those and what they mean. Just a memento. So, we have metals, non-metals, and semi-metals, okay? So, what do we know about metals? Well, we know that metals, number one, they are solid, right? They are solid, except for which metal? There's an exception. There's one metal that is not a solid. Anybody tell me which one? Don't be shy. I know you all by name. Anybody? Anybody will take a guess? There's only one metal that is not solid at room temperature. Going once. Going twice. So, I'll tell you what it is. It's solid except for mercury. Mercury, where do we find the metal mercury? Anybody knows where we find the metal mercury? Anybody? A thermometer. That's where we find mercury, right? It's a medical instrument. It's a liquid metal, so obviously when we check for our temperature, the doctor's office or whatever, or we have a thermometer at home, the liquid that would rise in the thermometer would be mercury, right? Liquid mercury. Okay. And it's the only metal at room temperature that is not solid. It is liquid. Okay. There's another point about metals though. They have high boiling points, right? High boiling points. And as well as melting points. So both are very high. High boiling points and high melting points. And also the last thing, which is obviously quite intuitive, they are very, very good conductors of electricity. Right? We know this because every electric fence is made out of metal, by the way, even though it's wire. Alright, metal can be beaten into sheets or wire, which we see when it comes to the wires of electric fences. So, don't touch it, or else you'll shock. So that was metals. Let's have a look at non-metals. So a good example of a non-metal is water, because it's liquid. Okay. But non-metals, they can be solids or gases. Took me a while to get to that word. I didn't know what I wanted to say. And or, so I was kind of debating in my head which one do I say. But maybe solids or gases. Okay. Many non-metals are gases at room temperature. Okay. So if we have a look on our periodic table, okay, we have non-metal, which is this blue over here. So nitrogen's a non-metal, carbon's a non-metal, oxygen's a non-metal, so sulfur. All these little elements over here would be a non-metal. A little sad con about non-metals is that, well, they are not good conductors of electricity, right? So they're bad. Okay, not good means bad.
But then why can you shock if you are touching water and like lightning or just I don't, okay, never mind.
You see, the thing is with that, okay, maybe I'll just discuss this off the air. And the last one that I just want to go through is, of course, the semi-metals. Okay, semi-metals. Okay, semi-metals. All right. They are, of course, are solids. All right, but they have properties. Okay, they have properties of metals and some properties of non-metals. So they can act as both if they so choose. Okay, let's take for example here silicon. Okay, so we have silicon over here, which is Si on the periodic table. If you have a periodic table with you, you'd like to go check where it is, go ahead. Is a solid element that is shiny like a metal. Alright, so it's shiny like a metal, has that metal property, but it is a poor conductor of electricity as well as a poor conductor of heat, just like a non-metal. So there you have a element on the periodic table that in fact has both properties of metals and non-metals, meaning it looks like a metal, shiny like a metal, possibly could feel like a metal, but it can't conduct electricity very well like metals do. Now, if we have a look at the periodic table here quickly, we have names for rows and columns, special names for rows and columns on the periodic table. Okay, so we have, obviously, rows are the horizontal, and we know that groups are vertical. Okay, so now what we do is that we define the rows in a periodic table. We call them periods. Okay, and we call the groups, or the vertical columns, we call them, wait, am I talking nonsense? Let me just check quickly. I'm mixing up my terms, sorry. The columns are called groups, not the groups are called columns. I was going to write the groups are called columns, but the columns, which is what I've been saying the whole time, like a retard. Anyway, columns, they are called groups. Okay, so example, back to the periodic table. So from hydrogen to helium, that would be considered a row. All right, here we have lithium beginning of row 2, going through to I need to see what that is. It's a bit too small for me. Neon, that's what it is. There we go, neon. Okay, is row 2, or more specifically, period 2. And then starting with sodium is period 3, and then potassium starts at period 4, and then all the way down to period 7 over here, all right, which starts with francium. Okay, francium. And then, of course, we got groups coming down. So hydrogen here, starting go all the way down here to francium would be group 1. And here we have Be, which is beryllium, and we're going all the way down to radium, which would be group 2, and so on and so forth until we get group 18 at the end here, which is your noble gases. All right. Cool. So everybody understands the periodic table in that respect. Okay. So all the periods, all right, in or all the elements in the periods, all right, they all have the same number of orbitals, right, for the electrons. Okay, if we have a look at the example in period 1, okay, where we found hydrogen, which I'll just zoom in again for. Okay, so we found hydrogen over there. Period 1, all the elements in that period have the same number of orbitals, which means that it only has one orbital because it only has one electrons. All right, because it only has one electron there, all right, in each period. So every element in period 1 would only have one electron, and every element in period 2 would have 2. Does that make sense? Okay, the maximum number of electrons for each element would be 7 because there are 7 periods. So from period 1 all the way down to period 7, alright, every element here would only have 7 orbitals, or 7 orbitals for their electrons. Alright, hope that makes sense. Then we go to the group. Okay, groups. Okay, now the elements in each group, they have the same number of electrons in the outermost orbital of the electrons. So if we have an example here, let's take group 1. There is only one electron which matches that of the period. One electron in the outer orbital, or the outer shell. Okay, if we have a quick little drawing here quickly, if I have a little circle, and there is, right, one orbital, 2 orbital, right, if we have the nucleus in over here, okay, we'll find one electron over here that's available. Okay, if there was another one over here, no, this is not a best drawing, there would be 2, right? Or if there were, as the groups continue, there are more electrons is available in the outer shell. So then this would be group 1, and then group 2 would have another one, and group 3 would have another one, and group 4 would have another one, etc., etc., etc. Okay, but when we go to group 18, All right, the elements in group 18 have an outer orbital that is full of electrons, and they actually cannot hold any more in group 18. Okay, so they cannot. An element on the periodic table cannot hold more than 18 electrons in their outer shells. Okay. If we have a look here, the periodic table, which I'll show you again. Okay. There are only two elements in period 1, which we can see is hydrogen and helium. Okay. This is because the first orbital can only hold up to 2 electrons. Okay. Can only hold up to 2 electrons in the first orbital. But period 2 has 8 elements because the second orbital can hold up to 8 electrons. So the periodic table is completely well structured. Okay, they will not really test you in depth about the periodic table in this regard. This is just for understanding how it is set up. All right, and that there's no, it's not set up willy-nilly. All right, they didn't set it up as they found more elements along. Okay, they grouped them specifically in periods and in groups. All right, so the table of periodic table of elements can make sense. All right, in the chemistry world, of course. Okay. Now, something I just want to mention quickly is we see that we have a certain element. I just want to pick something like carbon, or for a second, or let me pick something like sodium. It doesn't really matter which one I pick. Okay, so let's say we have a this is one of the squares on the periodic table. Okay, doesn't look like this, but draw it the best I can. So we've got sodium and Na. Okay. Now we know that sodium is the symbol. Okay? Sodium's the name. So we've got sodium. But Na we know is the symbol. It's the periodic table of elements symbol for sodium. Okay. Then there is a number. Okay. If we go to sodium quickly, you'll see there's a number over there. The corner we will say 11. And there's another number at the bottom that says 22.9. 22.99. Okay, what do each of these numbers obviously mean? Well, we'll do them both different ways. Okay, firstly, okay, the number 11 is what is known as the atomic number. It's known as the atomic number. And then the number which is usually at the bottom, or the bigger number, okay, because sometimes on some periodic tables, fellas, they are swapped around on some periodic tables. Okay, but this is the most common looking periodic table. It will be in this format. Okay, the bigger of the two numbers would be what is known as the atomic mass number. Okay, or just atomic mass. Okay, in other words, it's the mass of the atom, 22.9. Right, or what is known as 22.9, and it's measured in grams per mole. You don't have to worry about this just yet, because we will learn this only in grade 10. Starting from grade 10 all the way through to grade 12. It's fun. Don't worry about it. It's okay. All right. Pretty cool. Okay. So, let me just rather say that we only work mostly with the first 20 names of the periodic table. Okay? We usually work with the first 20. Oh, not first 20 names rather, but first 20 elements. Okay? We usually just work with that, with the first 20 elements on the periodic table. So that means we start all the way from hydrogen, and we go all the way down to the 20th element, which would be, I think it's zinc. All right, let me just have a look here. The 20th one. Oh no, that's wrong. Sorry. So calcium is actually the 20th one. The zinc is actually the 30th. Okay, so it's not even, it's not the first 20, but we actually work with the first 30. Okay, so usually up to zinc we will go through with. Okay, so let me just fix that, not 20 but 30. Okay, right, so just correction, that is the first, it's between 20 and 30 to be honest, so let's maybe just put that here for the video purposes. Okay, first 20 to 30 elements. Okay, so hydrogen usually down to zinc. A good way to remember it is to use flashcards or cue cards, however you want to call them. So let's say this is the one side. Okay, I'm not sure if you guys have maybe used this technique before, whether you have or haven't. It's a good way to refresh your memory as well, like you're playing a game. So the first 20 to 30, whichever, because usually your teacher would assign, all right, learn the first 20 or learn the first 30, you know, depends. So this is the one side, all right, and maybe you write down the symbol, all right. So this will be the front of the card, and then the back of the card, which the other person would obviously have facing them. All right, you won't see the back, but the back of the card, of course, can be the answer to the symbol which we see on the front, okay, which will obviously be hydrogen. Okay, and that's how you play with memorizing, because usually the periodic table that you'd get for a test or an exam will not have these. See these names here, there's names here underneath the elements. It'll not have that. It'll just have the element's symbol, and you must know that it is hydrogen if it's H, all right, or Ni if it's nickel, you know, or Zn if it's zinc. All right, you must just know that. So this is a good way to practice, to make sure, of course, that you get that part sorted out. Okay. Right, the chemical name of a compound is worked out using the elements that make up that compound. For example, if we have a compound that's called sodium chloride, all right, we have sodium chloride, all right, so we know obviously it has sodium, which is Na, and chloride, meaning it must have chlorine, Cl. Okay, let's use bigger brackets to make sure I'm not using two C's. Okay, Cl. Okay, that's a L, by the way. Cl, that's the cursive L. Okay, chlorine, sodium chloride. Okay, sodium chloride is also known as table salt, the salt that we would put on the table when we'd like to throw over our fish and chips or some. Okay, table salt. Okay, now it's made up of sodium and chlorine. So what the chemical formula look like? The chemical formula would look like this. Okay, let me just specify it. Na for sodium, Cl for chlorine, Cl. Okay, let's take another example. Example 2. Let's take hydrogen sulfide. Hydrogen sulfide. Okay, now we know sulfide obviously relates to one element of on the periodic table, which is sulfur. So we got hydrogen, which is H, and sulfur, which is S on the periodic table. Okay, but the chemical formula for it would be, because hydrogen cannot exist on its own, so hydrogen will have H2. So the chemical formula, which I would nickname CF, would be H2S. All right, and so on and so forth. The second part of a compound's name tells us what group of atoms is attached to the main atom. Let's have a look here at chloride. Okay, we know chlor is for chlorine, but let's have a look at the ending. It's got ide, IDE, chloride. All right, chloride is used for chlorine. Okay, sulfide, which we see here in the second one, is used for sulfur. All right, and then oxide would be used for oxygen, for example. Okay, oxide. Okay, so another example would be CO2, which we know is what? Carbon for the first one. Keep that name for the first element. We keep that name the same. Carbon dioxide. Okay, now something that's probably jumping the gun slightly, okay, is that the di part, di, okay, means two. All right, it means two of. Okay, so I have two oxygens here, so dioxide. All right, and then I still have my "ide" at the end here. Okay, obviously tells us the group of atoms that is attached to the main atoms. Okay, does that make sense to everybody? Some compounds are more commonly known by their common names. So if we have H2O, we'll never call it, for example, hydrogen oxide. Okay, it's known as water. H2O, it's called water. And then another one which we would use is ammonia. All right, ammonia, which is ammonia. Let me just take away the arrow as well, which is also known as NH3. Okay, it's ammonia. It's also known as NH3. I'm writing foolishly. Sorry. Okay. There's no other, well, I'm not saying that there's not another name for it, but it's just that it's what's more commonly known by, or better known by. So it's called common names. Okay, so water, H2O is water, and ammonia, NH3, it's known as that, ammonia. Okay, and the list continues. For example, salt is a common name of sodium chloride. So we will never say, if we were at the dinner table or lunch table, whatever, can you please pass me the sodium chloride? Would you please pass me the NaCl? No one will know what you're talking about, right? But everybody knows what you're talking about when you say, please pass me the salt. Okay? If we have pool acid, all right, now pool acid is known, is hydrogen chloride or hydrochloric acid's common name, all right? Pool acid, all right? The acid we throw into pool, right, that kills all the algae, so you can have a clear water pool, right? But if you swim in a pool where they've just thrown HCl into, your eyes will burn. Okay. And another example, if we have sodium carbonate, okay? Sodium carbonate is its scientific name or chemical name, but it is more commonly known in an average household as washing soda. Okay, if we take another one, just quickly, we have sodium bicarbonate. All right, sodium bicarbonate is a chemical name for a chemical substance that does exist, but in a normal average household or on the streets, if you want to call it that much, in everyday life, it is known as either bicarbonate of soda, that's its common name, all right, or baking soda. Okay, so some chemical compounds, although they have chemical names, which is very true, of course, they do have common names that they go by, all right, which is okay, right? It's absolutely okay. But it's very important that we do learn, and we do make it a point of urgency to learn the chemical names, as that's what's going to be, it's going to count in our exam or our test. And that concludes my presentation for today. Grade 9s, please stay tuned for the next video where we will look at the extension of naming compounds.